1.2, we're going to look at mathematical models. In this sections, what we're going to look at is uh, a real life problem, and we're going to translate those real life problem into a mathematical model, which is formulating it, either equations or functions. And then we're going to solve, all right, the equations or evaluate functions with the various techniques to get a result, which is the mathematical conclusions, right? Numerical value. Then we're going to use that numerical value to translate it into the real life, you know, indications, which is another way of saying is interpreting the numerical values. So this is the process that we want to sort of review on it. And what I want to do is there's a lot of models that we can construct it, right? Linear, quadratic, uh, using the trigonometry functions, right? So many of them, but we want to focus on only a few of them to um, review it. So the first one is um, giving you an idea or recall on how to rewrite a polynomial functions, right? So in this case, it's given to you the zero of the polynomial functions, which is f of -4, f of -2, f of 2, and f of 4 is equal to 0. So the function value is 0. So when x is the x value -4, -2, 2, and 4s are known as what? 0 of the function. Right? So that's the information that we have. And another information that we do have is what? Um, a y-intercept, which is x is equal to 0, and then my output value is 6. So from the college algebra or from the pre-calculus, we learn how to write the polynomials with their zeros, right? And the question is asking us to write 4-degree polynomials, and we do have 4 powers. We do have like 4 zeros, so therefore I will be able to write them. So a quick recall is a polynomial functions with the zeros. We can rewrite it as in terms of factors of the zero first, c sub 1, x of c sub 2, and x of c sub 3, and x of c sub 4. So this is basically because I only have 4 zeros, and then we are interested in putting into 4-degree polynomial. So I just stop it right here. Actually, like, you can continue as far as you want, as many factors you want, if you know the numbers of zeros and then the numbers of polynomial that we're looking for, right? The degree of polynomial that we're looking for. So uh, this informations, right, is necessary for us to find out what is the leading coefficients right here. And without this informations, we will be only getting a general solutions, meaning, a polynomial of degree 4 passing through these, having those 4 zeros, not the specific one. We have a family of them. So at this point, first, we're going to try to substitute the zeros. So it'll be x. When c sub when the zero is -4, that will become what? +4, x plus 2, x minus 2, and x minus 4. So we got 4 zeros right here. Okay. Now, simplifying a little bit before we find out that this x, the value a, we can multiply it out. But a lot of times, if you multiply it out, it may be like, more difficult to do the computations. So therefore, using the factor formats is the recommended, right? So by knowing this situation, this information, f of 0 is equal to 6, I will be able to find out what is my value of a. So in this case, this is basically talking about my output value is 6 when the input values are 0. So this gives us, when we compute it, this gives us 4 times -4 is -16. 2 times -2 is +4, -4. So -16 and -4 is -64, right? So that will give me -64a. I should say +64a, my bad. Right? And finally, when I divide both sides by 64, that will give me 3/32. So this is what we get right here, right? For value of a. So finally, I can state that my functions f of x is equal to 3/32 x minus x plus 4, x plus 2, x minus 2, and then x minus 4. And we may leave the polynomials in factor formats if you wanted to. If you want to continue simplifying, all you have to do is multiply it out, and then I can use difference of 2 squared to multiply it out, these 2 factor and these 2 factor, and then after that I will FOIL it. Okay, and that will be the example number 1 that we want to recall for how to write polynomial functions with degree 4. And this idea can continue on, like, a higher degree also, as long as you have the numbers of 0. If we don't have the numbers of zeros, then we need to, approach it slightly different, but we need more information. Next that we want to continue is example number 2. Right? And this example is giving you an information, and then we want to construct, right, an equations or formula to answer the questions. So in an example, Johnson leaves Detroit at 2 p.m. and drive at a constant speed. And west along I-96, he passes Ann Arbor, 40 miles from Detroit at 2:50 p.m. Express the distance travel in terms of the times elapsed. What does the slope represent? So in this case, the problem is a constant speed. So that basically indicating that we are looking at linear model, right? And first off, to talk about this linear model, I can denote it as 2 p.m. as the initial times. So I will say that this t equal to 0. And 2:50 p.m. is where the times end that we want to look for it. So 15 minutes is basically 5/6 in terms of hours. You can write it in terms of, like, minutes as well, but I will put it, it's better to talk about miles per hour. That's why I'm just converting into hours. Right? So by saying, by denoting that way, then we can have 2 order pairs. I can say that the initial times will be 0, and that's where the distance travel is also 0, because we haven't traveled anywhere yet. And then we're gonna go to 40 miles after 15 minutes. So 5/6 will be 40 miles. And this will allow us to get the slope up, right? Because this is a linear model, because of the constant speed, this is a linear model, and then we can write the equation of the line. So my slope in this case is using y2 minus y1 over x2 minus x1, right? That idea. So when you simplify this, that will be 40 times with 6/5. So this will be 8 times 6 is 48. And this is the slope. And we know that this is miles, right? And per hour. So this is will help us to interpret one of the questions that's asking. So now, continuing this, I want to write an equations for us. So y minus y sub 1 equal to mx minus x sub 1. I can write it like this, right? Starting with point slope form, y minus either point, any points you want to use it, that's perfectly fine. Okay. I can use like 40, and then the slope will be 48, x minus 5 over 6. So no preference, I'm just like writing it out. So using the second point, you can use the first point also, which is easier, right? Which is, will be 48x minus 40. So when I add 40 on both sides, this will be 48x. So now I'm done with all the formulatings and everything already, right? But however, the question is asking us to express the distance travel in terms of the time elapsed. So I don't want to put my my equations or formula in terms of x and y. This is what we are used to with it. So now here's the actual problems come. I would say that, you know, let d be equal to distance travel, all right, and t be equal to what? Times elapsed. So therefore, my equation in this case will become a d of t in terms of functions. That is equal to what? 48t. Since this is a linear, this is the first part of the questions that's answered. And the second part is like, what is the slope representing? And that's the reason why I put the units right here when we find out the slope to help you to interpret better. So the slope is what? 48, right? So it's basically talking about the slope represent the speed, right? The constant speed. In this model. And that will be my final answer for this questions. So I want you to, you know, just focus on linear model. Like, you know, you can if it is a quadratic model and stuff, you already know how to create, you know, construct the polynomial functions with the zero. So it shouldn't be a problem either. Right? And the next example, the manager of the manufacturers find that it costs 22,000 to manufacture 10 chairs in 1 day and 4,800 to produce 300 chairs in 1 day. First, we want to express the cost as a functions of numbers of chair produced, assuming that it is linear. So this is important. That already tell us what kind of model that we want to create. And second, what does the slope represent? The slope of the graph, right? What is the slope of the graph and what does it represent? And third, what is the y-intercept and then the graph of the graph and what does it represent? So it's not asking you to graph it, right? It's asking us like, you know, what is the slope of the graph will represent and stuff. So in this case, we know that this is a linear model. It's given to us. So the information that we have is basically what? Two different data set. But the key thing is you need to know we want to write a function as of what, right? So that is on the first questions, express the cost as a functions of numbers of chair produced. So that basically tell us this is my output, the cost is output, and then the numbers of chair produced is what? Input. So that makes it clear for us to write, you know, a proper order pairs to continue. So with this information, now I can say that for 100 chair, $2,200, and for 300 chair, that is 4,800. So now I can use these 2 points to find out the slope of this, which is y2 minus y1, x2 minus x1. And this gives us 2,600, right, over what? 200. Now, dividing this, that will give us 13. And remember that this is talking about what? Dollar over what? The numbers of chair. So that way it will help us to interpret it easier, right? This dollar is basically what? The cost, right? So now using this point slope form and then finding out the linear model like before. So which is y minus, you can use either point. This time I'm going to use the first point, which is 2200 equal to 13 times x minus 100. So that gives me y minus 2200 is equal to 13x minus 1300. Adding 2200 to both sides, that will be y is equal to 13x plus, in this case will be what? 900. So now we got the models or linear models already, and we're going to write it down in terms of what the question is asking. So here's the first part. I would denote it that you really need to define this. You are in a level that you need to be able to organize and then structure and then present it clearly. Okay. So let, I would say that C will be representing the cost, right, of producing X units of chair, and let X be equal to what? The numbers of chair produced. Now that I already defined my variable, so I can say that C of X, that is equal to 13X plus 900. And that's the first questions. We are writing the cost as a functions of numbers of chair produced. Second, and the question asks you, what is the slope, and then what does the slope means? So in this case, the slope is 13, and it represents, right? It represents rate of change. Remember, we don't want to talk about the slope, slope all the time, because when it's a application problem, the slope is the rate of change, right? So this 13, the slope is 13, and it represents the rate of change for producing what? One chair, right? The rate of change in cost for producing one chair, because I have 13 over 1, right? So it's per chair. So this is the interpretations that you need to understand and being able to write it, right? And part 3 is asking you what is the y-intercept, and then what does it represent. So the y-intercept in this case is 900, right? And it represents, so in the linear models for this kind of like productions cost, when you are not producing, when x is 0, right, that means y-intercept is 1, x is 0, right? The when x is 0, that means like you are not producing any chair at all, but you still have the cost, because that cost can be what coming from, even though you don't have any order, right, to produce any chair, but you still need to what pay for the utility, rents, and then labor, like so on and so forth. So this could mean that it could represent, right, fixed costs, I would say. So which is like including utility bills, insurance, rents, everything. So that's how I will interpret it for this particular problem. And this is all what I want to go over, and then but you can continue exploring on looking at the textbook example for quadratic case and so on and so forth, because I already review a little bit on how to write polynomial functions. So if you have a quadratic case and stuff, it should be okay. But I want to, put extra extra example to review for you, just to give you an idea, okay, how to deal with this quadratic case, just in case if you want to continue looking into your in the textbook. So as you can see, when we talk about the linear model, right, we only need 2 points to write the equation of the line, right? Any 2 points on the line will help us to write equation of that line. But if you are talking about for the quadratic model, how do we write quadratic model if we don't know the zero of the functions? How do we do that? Right? For the quadratic model, what you need is you basically need any 3 points on the parabola, right? The quadratic on a parabola to write the equation for the quadratic equations. And the reason why is because, in a linear model, we only have y equal to mx plus b format. So I only have 2 variables that I need to look for. So 2 point is good enough. But in the quadratic, I have ax squared plus bx plus c. So I need to have 3 values right here to indicate the quadratic. So in the kind of situations, what happens is I need 3 points, right, on the parabola in order to write this equation, quadratic equations. Any 3 point is fine. So for example, how do we deal with that? Let's say this point is like, let's say this point is like, 3, 4, and this point will be 4, 1, and this point will be maybe like 5, 4, something like this. Then what we can do is we can use each point to indicate this right here. For the point 3, 4, right, I will be able to write an equation, which is my y value is 4, my x value is 3, so 3 squared plus b times 3 plus c. And this will give me 4 is equal to 9a plus 3b plus c. So notice that I have 1 equations with 3 variable. And if we want to solve those variable, what do we need? We need 3 equations, which is you need to get a system of equation. So for example, the next point, if I'm using 5, 4, then this will be what? 4 is equal to a 5 squared plus b times 5 plus c, which will be 4 is equal to 25a plus 5b plus c. So here's equation number 1, here's equation number 2, and lastly, using the last point on this parabola to find out the last equation, which is 1 is equal to a times 4 squared plus b times 4 plus c, and which will be 1 is equal to 16a plus 4b plus c. Right? So I'm giving to you like, an idea, and I give you an example with one random 3 points on a parabola, right? And now we have 3 equations ready. Now what we can do is we can use a system of equation to solve for it, which is I'll be looking at 9a plus 3b plus c equal to 4, and then 25a plus 5b plus c equal to 4, and then 16a plus 4b plus c equal to 1. So you may use elimination methods or matrices or calculator to solve for this, this system of equations with three equations with 3 unknowns, and then you will be getting ABC. And then when you plug it back into ABC into this quadratic, equations, that's what you're going to get your model. It's a little bit more complicated, right? But hopefully this is a review for you. You should learn, you should see that in your algebra course and then pre-calc, right? Somewhere. And this is what I want to conclude for these sections. And don't forget, the homework is already stated in the beginning of the sections. Here is the homework for these problem, and my homeworks are focused on the linear modeling part.